Hello everyone, and welcome to another episode of Teaching Mathematics. Today we're joined by Lidwinia. And Lidwinia, thank you for coming. You've come quite a long way, haven't you?
Yes, I've come all the way from the Limpopo province. Thank you very much for having me.
It is a great honor to have you. For those of you who don't know, we are based in Gauteng, so it was quite a drive, wasn't it?
Yeah, it's a 3-4 hour drive if you take into account all the valleys that I have to drive through.
Well, thank you again. And of course, we are joined by Dylan behind the buttons. Hello, Dylan, and welcome. And then why don't we start with you telling us a little bit more about yourself?
Well, Helen, I'm a teacher. I have been a teacher for more than 30 years. Actually, I shouldn't be mentioning all the years. And so I've been in the classroom for a very long time. But I've also been involved in exams as a senior examiner and a deputy chief examiner, and being appointed as a chief examiner of Limpopo. And then also lately as the internal moderator of Limpopo province.
And this is all within government schools?
That's all within government schools, yes. Especially, government schools, excluding IEB schools. They have their own exam department.
Yes, they do, yeah. Okay, now the topic for today's discussion is grade 11 analytical geometry, but we are going to go all over the place, aren't we?
Yes, we are. I'm looking forward to covering lots of topics.
Yes. But before we go on to that, I want to shake things up a little bit. For those of you who have been watching previous episodes, you know that at the end we usually discuss a book that I've been reading very slowly called Teach Like a Champion. But today's topic that is in the book for discussion is something that I thought we could apply to our discussion today. And if Dylan brings up the slide, the topic is begin with the end. And I wrote a brief summary on the side. It's not Doug Lemoff's words, it's mine. It says good planning, know the end goal of the section, and then know the end goal of every lesson. This doesn't only apply to content and skills. What is the big picture? And basically what this actionable step is saying is that when you start a section, know what you want the students to know by the end of it. And it doesn't only apply to the content, it applies also to the skills and maybe some other skills, world skills that you would want them to learn as well. And once you know the big picture, then you can plan each lesson according to what your outcomes are. And it's, the South African teachers hate the word outcomes because of OBE, but basically that's what it's looking at, structuring your planning so that you know at the end of each lesson.
Yes, that's true.
I'm going to have this so that at the end the big picture will be this. Now with that in mind, why don't we take a look at your 5-point teaching strategy, where it shows us basically what is the end outcome of grade 11 analytical geometry.
Sure, yeah. So the end outcome of grade 11 analytical geometry is basically to be able to apply the formulae for distance, for gradient, for the equation of a line, and then also in the end for the inclination of a line. That is the angle that the line makes with the positive x-axis. Yeah, and if you know that you have to teach all those things and you have to be able to apply them, you also divide your lessons and your available time into what has to be done in each lesson, so that you get to the final goal.
And it's a 2-week section, analytical geometry.
It's a 2-week section in grade 11 and then a 2-week section in grade 12 again, yes.
Okay, and they have done some in grade 10 as well, and...
Yes, they have done the distance formula, they have done the gradient. Actually, the gradient comes from grade 9 algebra already.
Yes.
Where they do have to calculate the gradient of a straight line. So, yes, the learners do understand that concept by the time they come to grade 11.
So basically, the only new thing they're doing in grade 11 is inclination of a line.
Yeah, they're doing the inclination of a line, and then they're also integrating a lot of Euclidean geometry. So in grade 10, it'll really be just calculating the distance between two given points and the gradient of those 2 points. But in grade 11, they'll start presenting the kids with the big picture already.
Okay.
So they'll give polygons in a Cartesian plane. And then they also have to prove the properties of polygons by analytical principles. So in grade 10, you might learn that the sides of a parallelogram are parallel.
Yes.
And in grade 11, you have to prove that by calculating the gradient of each of the sides and showing that they are, in fact, parallel.
Those polygons, are they taught in the measurement section of grade 10? I'm sorry, I've thrown something at you.
No. They're not taught into measurement. I think measurement is volume and surface area and stuff. So polygons are in Euclidean geometry.
In Euclidean?
Yes.
Okay.
And we will integrate Euclidean geometry very much into analytical geometry.
Okay. Well, let's take a look at those 5 points that you've written down. I'm going to read them out. The first one says, revise the grade 10-11 formulae for distance, gradient, inclination, midpoint, and how to determine the equation of a straight line. Nothing really groundbreaking there. You're just going over the formulae and you're saying this does that, blah, blah, blah.
Yeah, excluding the inclination there. Okay, so yeah, the inclination is actually the goal we have in mind at the end, yeah.
Okay. Point 2, use a geometric figure with given points in different quadrants to calculate the different quantities. Discuss the validity of answers and common sense ways to test validity of answers. This is a common problem, isn't it? Common sense.
Yes, this is quite important to me, that children are able to not only solve problems, but actually understand where the problems come from and understand the answers. And it's actually when kids started using calculators,
yes,
they lost their ability to estimate answers. So they get to really answers that are really way out, and they're not even aware that those answers are wrong. So what I do teach very vehemently in my class is every time you get to an answer, ask yourself, does this answer make sense? So if you have a distance, for example, if you're working in a triangle and two of the sides are 5 and 7 centimeters, and you have to calculate the length or the distance of the third side of the triangle, and you get an answer of 87,2. And most kids are just very comfortable with that answer.
Yes.
So I really push in every lesson to ask him, does this make sense? Because that is also important when assessment is done, when they're writing tests. They can actually catch themselves making mistakes when they have learned the technique of seeing whether this answer makes sense or not. So
yes,
as we said, validating the answer.
Yeah. I think it's an important point in this section.
Yes, even grade 12 children are very happily find the equation of a straight line, and you can obviously see it's a forward slope line, and they're very happy with the negative gradient and substituting a point, often which is not even on the line.
Yes.
So I do encourage learners drawing sketches all the time and seeing the point that you're substituting, actually making sure that it's on the line which you want to calculate the equation of.
Yeah.
Otherwise, you're just doing all kinds of abstract stuff, which most learners think. They do think that maths is abstract. And this section, Analytical Geometry, actually shows you that it's so practical.
It is practical.
I can see everything that I'm calculating.
Yes. And for that reason, you can actually make it a lot easier for them to understand.
Yes, that's right.
Point 3 says revise general geometry terminology and properties of different quadrilaterals by drawing them, discussing properties of diagonals, angles, and sides. Of course, everyone forgets about the diagonals, don't they?
Yes, they do. And for instance, in different polygons, like in parallelograms or in a rhombus or in a square or whatever, diagonals have different properties. Sometimes they bisect each other perpendicularly, and sometimes they don't. And they think they actually have to learn that, but you don't. If you just draw a parallelogram and you draw it with long sides and with a short breadth, then you can actually see that the diagonals will never bisect each other perpendicular. They're just making one acute angle and one big obtuse angle. So I never used to, at school even, I never used to learn basic principles. I used to just derive them from sketches that I made for myself.
That's a good thing to teach them.
Yeah.
The less they have to remember, the better, because then they can just apply understanding rather.
That's right. And that also encourages a love of mathematics, a love of the practicalities and the way that I can just, that one thing just leads to the other thing.
Yes.
And that it's so easy in the end.
It's lovely that way. Yes. Point 4 says, provide one problem with many sub-questions which has to be solved by integrating all of the above.
Yes, I'm actually a big fan of simplifying problems because a big part of your class will have a problem with mathematics. There will be a lot of angst in the past having not succeeded in mathematics. So you want to present them with a simple problem and also with points that they can see in which quadrants they are. And then you want them to do lots of calculations with those same points.
Yes.
So you want them to do the calculations, not confusing them with unnecessary data.
Okay. And that would be the point that you indicate that. Yes, Dylan.
Sorry, Helen, I just want to jump in here quickly. We've spoken a couple of weeks back about functions.
Yes.
And there we mentioned one of the strategies to use is to introduce one change at a time.
Yes.
Get them used to vertical shift, then
Yes.
horizontal shift.
Excellent.
Is that the same approach that you're advocating for here? Introduce one type of calculation at a time and allow users to get comfortable with that before moving on?
Well, actually, functions lends itself so beautifully to that because I actually have a worksheet and I make learners fold it so that first we just work with A and then we work with a vertical shift, so that's Q, and then we work with a horizontal shift, and that's P, and that's beautiful. In analytical geometry, you actually have the formulae already, and you have to apply them to different situations. You might then just add more information, yes, as you go along. But I don't think it unfolds as beautifully as parameters in functions. No.
Okay. And then the first 4 points obviously apply to both the grade 11 and a grade 12 class. But when we get to point 5, you're talking specifically about teaching grade 12 content there. So that step you would apply only in a grade 12 class. It says introduce the basic principles of the prescribed grade 12 content, equations of circles, and that's with the center on the origin or off the origin, as well as equations of tangents to a circle.
Yes, actually, grade 11 teachers can relax, knowing that there isn't much content to be introduced later on. So the grade 12 teacher starts with all the grade 11 principles, all those formulae that the children already know. And grade 12 content is actually a very small step that you have to take before you know everything about analytical geometry on a school level. Yes, it's only about circles, and firstly you have the ordinary circle with the origin as a center, the point 0, 0, which is actually one of the old functions of the old curriculum.
Yes,
we
I
still
remember
had a
doing
circle.
it
X squared plus y squared is r squared.
Yes.
Which is actually nothing other than a distance formula, because it's from a point xy, you calculate the distance from point xy to the origin. So it's x minus 0 squared plus y minus 0 squared is actually that radius of that circle. And then when you move the center, and you move it to the center, which is then called, with two coordinates a, b, you actually just apply that distance formula again by saying x minus a squared plus y minus b squared is still your radius of your circle. So it's actually nothing new, and that's all there is to it.
Yes. I must admit I'd never thought of the formulae for circle as being the distance formula, but it makes perfect sense, and I'm a little ashamed now. But I would like to throw a spanner in the works.
Right.
So I am teaching grade 11.
Right.
This is me teaching my class. I have a class who's coping. They're not too terrible. They're not too bad. They're in the middle of the road. They grasp most of the concepts. The only new thing that's being taught in grade 11 analytical geometry is inclination of a line. Can't I start with point 4, where you say provide one problem with many sub-questions, which has to be solved by integrating all of the above, and do an enrichment activity like that? Give them a couple of points, tell them that they need to solve a couple of questions, exam-style questions, and give them the formulae. They must just apply them.
Okay, you're saying so you want to start with an example leading up to the inclination.
What if we let them discover angle of inclination by themselves? So we start with an example that's finding the fourth point of a rectangle on the Cartesian plane.
Okay.
And we tell them, try your best, go for it. And then we use that example later on to talk about angle of inclination. What are your thoughts?
I would like that very much. I like the investigation part where you put something on the board and you actually want to you want them to discuss it and you want them to come to that formula. I'm just not very sure if I would do that in the first or the second lesson of analytical geometry, because what I usually like to do is I want the whole class on board. I want the whole group on board.
Yes.
So there's lots of children there that have been having lots of problems with mathematics.
Okay.
And what I want to do to get them on board is I want to create a safe environment for them. So what I want to do, I want to give them problems that they are able to solve. So at the start of analytical geometry, I would go right back to stuff that they really can do, that they really can feel good about.
Okay.
And then when I have all of them on board, yes, I would do something like you suggested. I would put the parallelogram on there and find the fourth point, as you said, by using translation maybe. How many units has the one point translated on the horizontal axis, and how many units has that point translated in the vertical direction? So that's the way to find the fourth point. And yes, you are right. Inclination has in fact actually been taught already, because they know that tan of theta, tan of any angle, is equal to y over x.
Yes.
So they can draw the triangle there. In previous lessons, we also saw that a teacher who teaches analytical geometry also encourages the triangle being drawn there.
Yes.
So if they finish that triangle, they know that it's a shift in y, or a shift in the vertical direction, over a shift in the horizontal direction. So they have enough knowledge. Yes, that would be quite interesting to see how many kids, because usually in mathematics, kids think into compartments.
Yes, they do.
And they're not really willing, if they're in an analytical class, they're not really willing to think about trig. Not lots of children. Lots of children don't want to think about trig, because that's quite abstract.
Well, by this stage, they've been doing trig for weeks now, haven't they? They've done trig functions and then
and they
reduction
usually put trig functions in a separate compartment as well. Yes,
yes,
you're
they
right.
do. They don't quite. When did they do trig equations?
Trig equations is still coming up, I think.
Still, okay.
Yes, I think it's towards the end of the year.
Okay. I'd like to push this point a little bit more.
Right.
Because I quite like the idea. And of course, because I'm not teaching anymore, I don't get to test it. But you are teaching, so I get to ask you. I give them 3 points. I don't draw it on the Cartesian plane. And I say, find the fourth point of the... Let's go with the parallelogram.
Parallelogram.
Yes, because then they've got to find the midpoints of... and to find the center, and then...
You can do it by that method, or you can also do it by translation on X and Y.
Now, surely, if you give them a pack of resources, that say this is a gradient. Well, have those three formulae, the gradient, the distance, and the midpoint.
Yeah, they're on the formula sheet also.
Yes, and then also have diagrams of a parallelogram, a rectangle, and things like that, with all of the information drawn into it. Wouldn't they be able to... Are you saying that that would destroy their self-confidence if they are just given those 3 points and no scaffolding? Or would it build an inquiring mind within mathematics?
I think for each kid in the class it would be a different experience. I think lots of children, as soon as you give them something and you step down, because the South African school system is very much, I could almost say, teaspoon related. The teacher
Yes.
stands in front and talks a lot. And then as soon as the teacher stops talking, that's actually your cue for starting to fool around. So as soon as you put a problem on the board, 80% of the children do think that this is actually now time to take a breather. But okay, let's say they're all mathematically minded, and you get them into interesting groups, and you lead them, and you ask them, okay, maybe you could connect a certain reward to who comes up with the answer first. I'm sure that if you stimulate them enough, yes, it wouldn't be too far-fetched to come up with the inclination.
So you're saying that they would need to be mathematically minded in order to...
In order
do
to have the
this.
confidence to venture out into new terrain. Yes.
So it's more about confidence than it is
It's
about
very much
knowledge.
about confidence. I'm actually glad that we're getting to this topic now of confidence, because, and we were also talking previously about a safe environment.
Yes.
Kids feel very unsafe in a maths classroom.
I don't know why. You don't look scary. I don't look scary. Maths teachers aren't scary.
Yeah, you're right. I'm always thinking, what are the primary school teachers doing to these kids? I'm actually always thinking, maybe primary school teachers just give them very abstract things to solve, and they don't give them tools, and then
Yes.
they have this whole fear that builds up. Yes, but the product that we get into grade 8 in high school is very much afraid of trying something new.
Yes.
I think we've also by that time destroyed a lot of their creativity because we're so prescriptive.
Yes, we are. But that's a topic for a whole nother
Yes,
show. We
I'm
could talk
sure.
for ages
And
on
if I
that.
can quickly jump in here.
Yes.
Just on the point that you raised now, kids coming into grade 8 feeling afraid of maths. How much do you think that is a factor of there's actually no celebration of being wrong? There's no leeway or latitude given for kids to experiment and to get stuff wrong. That actually if you're getting stuff wrong, you're not learning. Isn't that the message that we constantly are giving kids? And isn't that somehow part and parcel of this very prescriptive education culture that we tend to have in South African classrooms?
I couldn't agree with you more, Dylan. And I'm sure primary school teachers would crucify me. But I think that the fear happens there. And I think the time is also there in primary school. In secondary schools, we don't have time to
Yes.
celebrate lots of children doing lots of wrong things. But I think in primary school, but then I think we should change our whole system where the best and highly educated teachers should go to primary school, where teachers have the confidence to handle children being wrong. Because if a child says something wrong and you have enough experience, you can turn it all the way around to, yes, my boy, you really have a point there, you know. If we looked at it your way, you could be right. And if we did it this or that way. So, yes, I agree with you. We should celebrate wrongness or incorrectness more, and we should be able to turn that around. But if teachers don't have enough experience, they also don't feel safe enough to do that. They also feel like they're being put
Yes.
bare in front of their classrooms.
Now, I remember when I first started teaching and I taught a concept the wrong way. I felt so ashamed. I can still
Yes.
remember the exact lesson and having to go back the next day and tell this group of teenage boys that I had taught them something wrong. And of course, for the rest of the year, I had to fight to get them to believe me after that.
And actually, you could turn that around, because I think you would get a lot of cooperation in class if you said, and I do that often, I say, good grief, guys, I'm stuck. Can you help me? And then if the teacher is stuck, I'm kind of, so can't I help her? And can't I just contribute? So, if you have enough confidence to say, I'm stuck, then you get a lot more cooperation.
Oh, yes.
And you can bring in a lot of angles. But then, again, in secondary school and in grade 11 and 12, there's so many topics that you have to get through, that there isn't that much time for doing that.
Yes.
Is this topic not perhaps an opportunity to just bring back a little bit more of that?
I think what we should get to, and what I wanted to mention today, is this topic really enables the teacher to get away from the whiteboard and to get away from the front of the classroom. Yes, I think you should put problems on the board, and you should get away, and you should just walk around and talk to children and look at their approaches and look at their methods that they use and celebrate what they're doing. Yes, I think you're right, Dylan. I think this topic lends itself in an excellent way towards the teacher coming away from there and being prescriptive.
And you're saying that this should be done by first teaching the basics, getting their confidence up, and then putting the 3 points on the board and finding the 4th point. I'm not even sure if that's in the CAPS, if you have to teach finding the 4th point of a parallelogram.
Yes, it is definitely in the CAPS document. And we were always unsure in the past, because you could find the 4th point of the parallelogram by finding 2 equations of those 2 sides that intersect there, and then solving the equations simultaneous.
Yes.
But then we would always tell our learners to look at the point allocation, the mark allocation. And if it was 6 points, you would go the simultaneous equations way. And if it was 2 or 4 points, you would just translate.
Now this brings up another topic I was hoping we would get to, and that is, with this kind of section, it is quite easy to get them to do the work and to get the questions right if they follow a certain system.
Right.
And are we then teaching towards getting marks or teaching towards understanding? Honestly, I would be teaching towards getting the marks, because I know Sally Ann is not going to pass unless she follows a systematic routine over here.
Yeah, that's a very sad point that you're touching there, because I think currently in secondary schools we are teaching towards the assessment and towards the marks, because we have the external exams and we're being measured, and our results are being measured rigidly. So you're actually training children to write exams, whereas going back to primary school, okay, they've got the ANA exams now in grade. What do they have them in? Grade 7 and in grade 9?
And 1.
Which is
It's
actually
all over the place. 1, 4, and 7.
Yeah, which is actually very good, because you want, over the whole country, you want to get kids up to the required standard. So that's the advantage of ANA exams. But the disadvantage is that you're putting those teachers under tremendous pressure to cover certain topics, and to have children, to enable them to solve problems. Yes, and this pushes us more in a direction of formal learning and away from the intuitive and the joy and the fun. Yes, sadly.
And you could actually do a lot of intuitive and fun things with this section.
Well, I think as our country progresses and as our education, the standard of our education goes higher and higher, you have previous teachers that have done their work. So there's not a backlog, and you have time to play and to do fun activities and to explore and to do intuitive work, yes. So we're getting there. We are definitely getting there.
Yeah. Now, there was one activity we looked at before the show, doing distance activity, which I quite liked because I'd never seen it before.
Yeah.
Where it said the delivery man is going a certain amount of kilometers. Dylan, it's the top link. Thank you. Yes. And Dylan's going to open it up for us just so we can read the instructions. This link is to a blog, and it's from a maths teacher in the States somewhere. And he says he planned this lesson as he was, didn't take him long to plan it, but it took the students a long time to do it, and he turned it into a whole activity.
Yeah, that was a beautiful activity that he thought out, and it's actually very nice to use as an icebreaker at the start of a term. Because when children sit there and they think, oh, ma'am, do we really have to work on the first day? You could just devise this activity and write on the board where I think that guy was delivering pizzas or delivering some kind of ingredients from shop to shop or from pizzeria to pizzeria. And yes, I like the grid that it was done on, because he was also talking about direction, southwest, and then you could also link that to inclination, because southwest is in the middle of south and west, and that's 45 degrees or 135 degrees, and then you can actually use Pythagoras, see this distances, as we said. And then it also gets the children to work together, to use math terminology, because it's very important that they get those math terms on their lips, on their tongues. It's important that we get them to talk maths.
Yes.
Because you're right, actually, by saying that this activity, which actually just involved distance, will get them to inclination in a very spontaneous way. Yes. And at the end, you could really get to all your formula. Also, they were talking about a midpoint. So this activity at the start of a term could actually show them the way ahead, where we're going, and how easy it is.
It doesn't really show the end point, because the end point is, of course, the more formal testing, which is the type of questions we'd find on the exemplars and things like that. But maybe it does start conversations that are more interesting.
Yes, that's right. And actually we neglect that. We have to do that more often.
So we have 4 formulae that we need to go through in this section, and then the properties of the polygons. Really, a good teacher could teach all of those in 3 lessons. All of those, not a good teacher, but someone who taught, could get all of those concepts covered in 3 lessons, and you could have the next 5 lessons for practice. I'm not saying that's the best teaching style there, because of course, as you know, talking in the front of the class, you're going to lose 90% of your class. So where I'm going with this is, in grade 11, if we've got 2 weeks allocated to this and they're bored, can't we teach grade 12 content?
Yeah, we could. I think that would actually do no damage, because, like I said, the grade 12 content is just a little step above the grade 11 content. But I'm sure you could get lots of problems that you could solve also just with the grade 11 content. And also, I think by grade 11, they haven't really had time enough in Euclidean geometry to explore the properties of polygons.
Okay.
So while we're talking about it, I'm just actually thinking out loud. I would rather go back and capture more of those properties and maybe have them prove those properties with analytical methods.
That's a good idea.
And with analytical formulae, yes.
Yeah.
Without going to grade 12 and to circles if you go to circles, you have to go to the tangents of the circle. And you'll actually be amazed at how the whole syllabus is put together. It also takes into account the maturity of children's thinking processes. And for example, trig is very hard for children in grade 10. It's very hard for them. And lots of times you get grade 11 learners who haven't really mastered grade 10 trig concepts.
Yes.
So thinking about those thought processes and the maturity of the mind of a learner, I would rather go back to the polygons and have them play. Then we have playtime. If we go to grade 12 content, it's formal lessons again.
Yes. And I suppose it doesn't really benefit them in their, but now I'm talking about exams again, doesn't really benefit them in grade 11 exams to know grade 12 content.
Yeah, where it does benefit them is when learners enter Olympiads, then the grade 10, 11 and 12 learners write the same question paper. And then often I'm reminded that the children in other schools or the grade 10s or 11s that do well in those Olympiads must have been fast forwarded by a teacher.
Yeah.
Yeah. So there could be a method in that madness. If the child had the big picture sooner,
yes,
he would be able to apply all the concepts together or to integrate sooner. Yes. There would be a method in the madness, yes. I would actually maybe do that as extra lessons for the brighter pupils.
Yeah.
Fast forward them, because the brighter pupils are often very bored in class. So that's maybe also a topic that we need to raise. A teacher can never stand in front of the class and explain a lot of concepts if he hasn't made sure that the bright pupil has been catered for. So if you see one or two really bright children being bored, tell them to turn to page such and go to problem such and just solve it while you're talking to the other kids.
You don't think it creates a divide in the class?
Well, I think actually you have to create a divide in the class. I think that's very realistic. I think those are the layers of our whole society. And I think the lesser evil would be to create divides. The greater evil being having bright children just die in class because you never cater for them.
I agree. I do. Yes. It is quite a thought, though. But then what do you do about the lower child? Do you create a divide for him as well, or her?
Yeah, we don't really have children sit in different rows, but I think an experienced teacher would have his or her eye on those children, and he would cater for them always. Yes. So part of the experience of a teacher, or part of your job description, would be to differentiate always.
And do you make a verbal differentiation like you have with the higher functioning? You've said turn to so-and-so page. Do you then go to them, don't worry, I'm coming to explain this to you at your desk?
Yeah, I don't think you would make eye contact with the specific learners that you have in mind. I always make an open statement like those kids who would want to do extra work, you could maybe try this or this or that. And then the bright kids would know that was them.
Okay.
And often the children that are not that bright also don't feel like doing extra work.
Yes.
So you might just call it, you might want to do extra work.
Okay. I have to think about this more. I do. Okay, now we are going to move on to the 3 pressure points that you have identified for this section. The first pressure point says, by teaching or trying to find variables or equations without plotting all the information on the sketch.
Yes.
Why don't you elaborate a little?
Yeah, that's very important to me. As a head of department at our school, I often walk past classrooms of my junior colleagues or my colleagues teaching junior classes, and I see them explaining away in front of the class without anything on the board, or with on the board being lots of random stuff. And I see them talking, and I see children in class just looking everywhere but on the board. So what I'm saying is, you cannot stand in front of the class and talk about an abstract topic like maths without talking specific points and specific details, drawing specific lines, and actually having handed out worksheets with graphs, with kids having those points in front of them. So very, very important.
Yes.
Don't stand in front of the class and talk abstract stuff. We have to involve all the senses. We have to involve seeing, hearing, touching, feeling, smelling almost, color, everything, and involvement. Because a 13-year-old boy or a 15-year-old boy, he just gets lost so fast.
The thought has just occurred to me. What if in the first lesson you send them all out to the hockey field or the soccer field, somewhere where there's a cross marked so it looks like the Cartesian plane, and you assign them points. They stand in those points, and then, well, some of them stand in those points, and then you use string to demonstrate the distance, midpoint, things like that. Just something to get them out of the class. But then my counter thought is they're out of the class, they're not doing any work.
Yeah.
So how do you balance activities like that? Because obviously it's great to have variety in your teaching, and to involve all the other senses. But
yeah, you're right. I think you should always think of interesting activities like that. Another one could be, I don't know if you still remember when you were younger, you used to have a game where you could hide ships and
battleships
and whatever on specific coordinates.
Yes.
And then you hide it from the person sitting opposite you, and then that person has to guess where your ships are. And you could do that on the Cartesian plane. So you could hide, maybe even with the grade 10 class, you could hide your battleship on the coordinate -1, 3, or 2, -5, or whatever. And your person sitting opposite you should guess by Cartesian points where your battleships are. And you could have a competition where you could see who could first destroy or find all the ships.
Okay, I see your idea. I think it's great, but I would like to expand on it. How about you as a teacher draw up the battleship thing on a Cartesian plane? You fold it up, you put it somewhere else, and you write clues using distance, midpoint, inclination, things like that.
Excellent.
And whoever comes with all of the coordinates first gets a chocolate or
you know what, now you've got me thinking, because I could do even better than you then.
Oh, please, share.
Because I found a trend in the UK that they said the teachers are so busy with admin that you find yourself at 10 o'clock in the evening designing a worksheet.
Yes.
Why not? And the new trend is have your children design worksheets. Have your children then hide the battleships, find the coordinates, draw up the clues, and just swap them in class. So that way you involve the learners as well.
Yes. Okay, how about this? You do, seeing as grade 11 and grade 12 are so similar with those first 4 points, you get your grade 12s to draw some and your grade 11s to do it, and you swap and you have a competition between the grades.
Very good.
I don't know when they teach. I think they're teaching grade 12 analytical geometry at the start of next term, though.
Grade 12 analytical geometry, no, is the last 2 weeks of the second term.
Oh, so it's now?
Yeah, so it's actually now. It had to start yesterday.
Okay.
So well, if you'd wanted to design some worksheets, now would be the time.
Yes.
Yes, I'm actually also thinking about, if you're saying involve your grade 11s and grade 12s, lots of children who don't have confidence, if you involve them with your lower classes. So if you have a mentor program where your grade 8s or 9s adopt what you maybe might call adopt a genius. And you could have some of your pupils helping grade 8s and grade 9s. And as I've also experienced when I was in school, as soon as you explain to younger children, it's like a wow moment to yourself, because now you actually understand it for the first time.
Yeah.
So whatever you can do as a teacher, just to get that confidence boosted and to find children doing something right, to catch them doing something right, to catch them getting it right. Because success breeds success.
Yes.
So if they get something right, they are motivated on a much higher level to try the more difficult stuff.
Yes. Okay, your second pressure point says trying mechanically to use methods used in one problem on the next problem. So that means this worked on this problem and now I'm going to use it on that problem because they must be the same.
Yeah, that's actually one of my pet hates, that mechanical thing. And I was always also a section in the paper 1 part of mathematics, which is called completion of the square.
Yes.
In the old syllabus, when you and I were still at school, maybe, you much younger than me, we did that completion of the square mechanically. It had lots of numbers and stuff, and you had to divide and you had to square, and you didn't really know what it was leading to. Now, also in mathematics and in analytical geometry, often children just follow a method mechanically. And they don't understand what they're doing. They're just doing it. And that I would definitely discourage. I would definitely tell them that each problem has a different method and a different approach. And by drawing it, it shows you all the clues. Inside that sketch, it shows you from which angle you should approach this question. So that then is the opposite of mechanical. You draw it, you put in the data, you see what is asked, and it leads you towards the answer.
So you're talking about coming at it from an understanding point of view, not from a let's apply whatever rule is there.
Yes. And that also maybe implies the extra class teachers, because the extra class teachers often, the children go and sit there with their arms folded, and what I don't understand was actually my teacher's fault. So now I'm sitting here with my extra teacher, and they just have to do some mechanical explaining.
Yes.
Whereas that teacher should just say, no, what have you got? What problem have you got to solve? Draw it. Talk to me. Because lots of times when I have children sitting next to each other, helping each other, and I'm seeing that the brighter child is doing a lot of talking, I go to them and I tell them, stop talking, ask questions. And as soon as the brighter child starts to ask questions, it actually involves the guy having the problems, and it actually forces him to think.
Yes.
And as soon as you force that guy to think, you are away from your mechanical method, and you are in your real valid thought processes.
I think what you've said now doesn't only apply to extra maths teachers or helping each other. I think it applies to teachers as well. If we do a lot of talking, we don't do a lot of asking questions.
Yes, you're right, and it's actually important that we're talking about that. And I really want to make teachers aware of the fact that I always tell my junior colleagues, if the bell rings at the end of your school day and you are so tired and you're so hungry and you don't have the energy to do one more thing, and you're thinking that you've had a good day, you haven't. You've had a terrible day because you've been doing all the work. And the children have just been coasting along, and they haven't learned anything, because you don't learn by seeing, as you also mentioned earlier. Otherwise, you could just go to a tennis court and watch the coach play, and then you could play the next day.
Wouldn't that be great?
Wouldn't that be great?
Yes.
As with everything in life.
You watch someone else exercise and you lose the weight.
Yeah.
Yes.
If only.
Yeah, it is a valid point. The last point says helping the learners too much or too soon or too often and talking too much. And I think that is exactly what we've been talking about now.
Yeah, I could actually expand on that. We were at a maths seminar once, and we were also looking at what countries achieve the best results in mathematics and in mathematical teaching, and it is actually Denmark and the Netherlands and, of course, the Asian countries. And then they had videos of teachers in those countries. And those teachers actually go into class, hand out worksheets or put a problem on the board, and go and sit at the back of the class, going on with whatever they're going on with. And the learners go into their groups or separately, and they start solving those problems. So I would actually want to emphasize this strongly to teachers, to encourage more individual activity, to get your learners to work. Don't do all the work. You have to explain, of course, the basic principles, but as soon as you can, get away from that board. Get in your class, get walking around, put your hands on the shoulders of children, make contact, talk to them individually and help them individually.
It really helps to get to know the children in your class.
Yeah, it does, and it's very important to make contact, and it's also very important for learners to be acknowledged and to be actually seen.
Especially at this age group.
Yeah, you're right. And if they feel the warmth, I had my own child is not very good at maths, takes after his father. And his father also always told me, because to me, you do maths.
Yes.
But his father said, listen, this guy is like me. We don't feel like doing maths, but if you sit next to us and you give us warmth, you give us body heat and acceptance, we will then try to solve the problem. And that was quite new to me. That's quite new to people that do maths very naturally.
Yeah. Yeah, and I have a cousin who cannot add numbers together, just cannot. I've never understood why she can't, but a lot of my teaching practice, when I've encountered children like that, I've thought, well, what would I do for Astrid? If she was here now, how would I sit next to her? How would I do it?
What actually keeps me very humble in the maths class is my complete inability to find any address or to have any direction.
Oh, do you too?
I don't have any direction. I can get lost on my way home for a year before I can really drive home. And I can't visualize the road going up to a certain point. And that maybe makes me a better teacher, because I understand that everyone is wired differently.
Yes.
So just because you're brilliant in one aspect, you're not necessarily good in another aspect. So always understand that it might be difficult for people. But then what I learned is that's where I learned my whole thing of drawing the sketches, seeing where that point is. And when GPSs came in, if I can see the map and I can see the roads, then I can also memorize it easier. But I can't memorize it. I can drive it 10 times, I can't memorize it if I haven't plotted it for myself.
Now, bringing in the GPS and coordinates and drawing points and things like that, surely we could do some kind of activity with analytical geometry and plotting points, doing a treasure map almost.
Yeah, I think that's, because a GPS works with coordinates, analytical geometry works with coordinates. You need all of them to move from one distance to another. Yeah, that could be very interesting.
Could almost do a maths outing to town centre or something like that.
You could, especially if you were in primary school, if you had the time.
Even one lesson to do something like that?
I think it's important. Yes, I agree with you. It is important.
It's okay if you don't agree with me. If you say it's too much time.
No. I really think that we have to think real life, and that is real life, because I saw a poster the other day saying, I've gone through another day and I haven't used algebra at all. So we need to show learners where you can use algebra or analytical geometry. No, you are right.
I did have a joke with my maths classes that they'd ask, when am I going to use this? I'll say, when you become a maths teacher, you'll also use it every day. Yeah, okay, so on that note, if we were to do an outing of some sort like that, with finding coordinates and things like that, couldn't we get other schools involved? How much do maths teachers really talk to each other from other schools?
Well, I know there's a great need for maths teachers to talk to one another. I know that they're always asking, if we go marking at the end of the year and we have all those teachers together, they're always asking, why can't we come together? And why can't we coordinate more activities?
Especially with drawing up enriching activities like that, it takes a long time to draw up those worksheets.
You're right, and everybody is inventing his own wheel at 11 o'clock at night, every night, yes. Yes, we should coordinate more.
It almost feels like there should be groups of teachers who meet in particular suburbs or towns, if you're out in rural areas over there, and coordinating resources.
Yes.
You develop a worksheet on analytical geometry and I'll do it on trigonometric functions or
You're
something
right.
like that.
But then again, Mindset does good work.
Oh, thank you very much.
Providing a central place where you can find all those lessons and where you can find the worksheets and where you can do the revision.
So do you think by doing that we're maybe isolating teachers more rather than bringing them together?
No, I actually think that teachers have to set up their own groups with colleagues that they're comfortable with.
Yeah.
Because if you invite them, they see it as yet another chore. or yet another
Yes, that's true, isn't
activity
it?
they have to attend.
Unless, of course, it's at a really good restaurant.
And it
Possibly
was
a bottle of
sponsored,
wine.
and it was sponsored as well. Yes, that would be wonderful.
Yeah. Yeah.
Let's ask a question quickly. You said that teachers should get together and they should be exploring things together, but they don't.
Yes.
Why? What are the barriers that you face with your staff, with your team, with the teachers that teach in schools nearby you? What are the practical barriers for teachers getting together, and what are some of the solutions that might be applicable in getting over those barriers?
Okay, what I would say, very big problems that we face in our schools, the X-Model C schools, is that there's an infinite number of extramural activities, and the teachers teaching in the morning in class have to do them in the afternoons. So me, myself, as a head of department, have tried to get my own department, and we all feel comfortable together and we all love one another, and I've tried to get them together once a term in my house, and I've tried to motivate them and do different activities with them, and they come up with one excuse after the other. And I really understand that they do work a 12-hour day. So, you asking for a solution? The solution would be to outsource the extramural activities, the sport. The solution would be that there should be clubs for the sport, and parents or coaches or whatever, so that teachers could focus on their academic work. Because in the X-Model C schools, actually we don't have enough time to focus on our subjects. Yes, so teachers are in over their head with all the demands of the communities, because you're talking reviews, you're talking sport, you're talking debates, you're talking all kinds of activities.
I'm sure there are many teachers around the country applauding you right now. Yes. Okay, we are coming to the end of time, so before we end off, I'd just like to take a look at the links for mindset resources. If you are struggling with the content, you can take a look at these links, and I'm quite excited because the first one is a link to classroom resources, Analytical Geometry on the Cartesian Plane, and we haven't had any of those links up yet. Basically, it's a series of short videos which introduce the concept as if it was being introduced by a teacher. So it's very small steps, talk through each one individually, and then at the end it's got a task video which has some questions which are more test-like. It's a personal hobby horse of mine. I enjoy these videos quite a bit. And then the others are Learn Extra Live videos and Learn Extra Lesson. And I've explained the differences between those before, but basically all of those videos are roughly an hour long. And so it's not something, you'd have to make a cup of tea and sit down before you sat and watched it. Now these videos you can use if you are a teacher and you are struggling with the content, or you could give them to learners who, possibly those bottom two, Sally Ann, who's struggling, say, listen, why don't you take a look at this quickly? Someone challenged me the other day. Said that you could put these videos, you can't. You could put content onto a memory stick and give it to learners, and they would said, most people don't have memory computers to play that in, and I see that, but I also know that most TVs these days come with USB ports, and so you are actually able to distribute quite a lot of material. Also SD cards and all sorts of things like that. You can do that. You can hand it on. Okay, now that is done, Lidwinia, it's been wonderful having you. Thank you for making the drive, and it's been a pleasure having you today. And thank you, Dylan, for your input. Now everyone knows that I'm not talking to a ghost.
Yeah, that's wonderful having Dylan involved, and thank you very much, Helen. You were right, yes, the hour went too soon. We still have lots of things to talk about.
Yes, we do. Well, maybe next time.
Thank you very much.
Join us next week when we'll be talking about grade 12 work. Thank you for coming. Bye.